Good afternoon, viewers at home. This is Mathematics with Dr. OJ. In this video, we shall solve a tutorial question on sum of geometric progression. Kindly subscribe to my video channel by clicking the subscribe button below the video and the notification bell so that each time I upload new video, you'll be duly notified. Thank you. Example 1. The first term of a geometric series is 3 and the last term is 768. If the sum of terms is 1533, find the common ratio and nth term. Solution. Now let's try to write out the parameters given. The first term, a, is given to be 3. The last term, we know the last term for a geometric series can be found using a raised power n minus 1. The last term is same thing as finding the what? The nth term of a geometric series. If the last term is given, we use L to replace the nth term. Okay? And fortunately, the last term is given to what? 768. So we have 768 will be equal to, according to that statement, our A is what? 3. Then R, we don't know. Nth term, we don't know. Raised by minus 1. Okay. So in this case, we can form an equation. We can divide through by what? By 3. So dividing through by 3, we're going to have what? 3 in 7, that's 2. Remaining 1. In 16, that's 5. Remaining 1. In 18, that's 6. So we have 256 is equal to r raised by n minus 1. So we can write this as saying that is r raised by n minus 1 is equal to 256. Let's call that one equation 1. Okay. Now the next statement, if the sum of terms is 1533. Now we know that sum of n term of a geometric progression is equal to Sn is equal to a into bracket r raised by n minus 1 all over r minus 1. This formula will be used if r is greater than 1. Okay. Now, in this case, we have been given what the sum of that term is. We have been given the value of the sum of the term, and so the value there is what? So let's look at the value. Sn is given to what? 1533 is equal to, I hope you are following. Then our first term, A, is 3. Okay, so we have what? In the bracket, r raised by n minus 1 all over r minus 1. Let's look at this. Can 3 divide through so that we reduce this volume? Okay. 3 dividing this, that's 1. 3 in 15, that's 5. All right. In 3, 1. In 3, 1. So this is what? 511 is equal to r raised by n minus 1 all over r minus 1. So in this case, we can what? We can do some mathematical or operations here. We can carry out some operations by cross multiplying. It's okay. So by the time we cross multiply here, we have what? R raised by n minus 1 is equal to what? Is equal to 511 into bracket r minus 1. I hope you are following. Yes, that is when you cross multiply here. Okay. Now we can expand this and have r raised by n minus 1 is equal to 511r, that is 511 multiplied by r, then minus 1 times 5, that's 511. Okay, we have expanded that. So invariably, this can also give us an idea of an equation. So let's bring 511r here. So r raised by n, by the time 511 comes here, becomes minus 511r. Okay, then minus 1. I hope we are following. Then when this one comes here, we got what? Plus 511 is equals to 0. I hope you are following. So this will give us what? R raised to power n minus 511R, then minus 1 plus 511. That is what? That is plus 510 is equals to 0. Okay, I hope you understand. All right, now we could call this one equation 2 if we like. And now in equation 1, we can write this equation 2 as r raised to power n minus 511r is equal to minus 510. It's still the same thing. Okay, it's still the same thing. All right, good. Now in equation 1, we wrote something in equation 1. We know that equation 1 gave us because we have cancelled equation 1. We said in equation 1, r raised to power, that is where we have from L is equal to, a r raised to power n minus 1, and our head there, is equal to 768. Eventually we, when we put 3 here, that is, we recall, let's say we recall here. So when we put 3 as a, and we have our r raised to power n minus 1 is equal to 768. Don't worry, I'm taking you back a little just to remind us of what we had in equation 1. Okay, so r raised to power n minus 1 is equal to, when we divided this, we have 256. That is in equation 1. We just try to, since we have cleaned equation 1 from the board, we are trying to remind us of what we had in equation 1. Okay, now in equation 1 we have this. Okay, so this one can be written as r raised to power n all over r is equal to 256. That is, this equation 1 could be rewritten like that. So if that is rewritten that way, what follows is we can equally cross multiply here. By the time we cross multiply here, we have r raised to power n is equal to 256 r. Okay, so if this one comes here to form an equation, r raised to power n minus 256 r is equals to 0. I hope you are following. Good. Now let's call this one equation 3. Okay, we can now combine equation 2 and 3. Let's combine equation 2 and 3. Combine equations 2 and 3. Okay, by the time we combine 2 and 3, we're going to have what? R raised to power n minus 511r is equal to minus 510, and r raised to power n minus 256r is equal to 0. So equation 2, equation what? 3. Okay, now in these two equations we can do something to eliminate r raised to power n. Now subtract equation 3 from 2. So let's subtract equation 3 from 2. To do that, subtract equation 3 from 2. So we're going to have r raised to power n, because we have gotten what is called a simultaneous equation. Minus 511r is equal to minus 510. Then this one becomes minus r raised to power n plus, remember we are subtracting, around 256r is equal to 0. Okay, now when you are subtracting 2 from 1, that is how it should be. The minus sign will multiply through here. So this one cancels this. So we have what? We have a negative value here, minus 511r plus 256. So what we have here, so we are subtracting, okay, 5, yes, we have a remaining 0 here, 10, and 5 again, and 2. That is minus 255r is equal to minus 510. Okay, I hope you are following. So since we have minus sign at both sides of the equation, this will cancel this, this will cancel this. So r will be equal to what? Divide both sides by 255, 510 all over 255. So if you divide you have your 2. So our r is what? Is 2. Okay? Now we have known the value of our r. What other thing that we have to find? Now that we have known the common ratio to be what? To be 2. Now we can go back to any of these equations in order to know what's next. So remember, recall in equation 1. In equation 1 again, we have r raised power n minus 1 is equal to, can we still use that? Is equal to 256. Okay, now we have gotten r here to be what? To be 2. Just so we can do something there to get our n. Can do something there to get our n. Okay, now by the time you substitute for the value of r, what do you have here? So you have what? 2, that is, put r is equal to 2 in the equation 1. In equation 1, that is this equation, put r is equal to 2. So we have what? 2 n raised power minus 1, that is 2 raised power n minus 1 rather, is equal to 256. Okay, now do we have a multiple of 2 in 256? Yes, we do. So you can have 2 raised power n minus 1 is equal to 2 raised power 8 just by finding the LCM of 256. Okay, and now this has looked like the indices. It's looking like an indices. So 2 will cancel 2 here. You have the powers. You equate the powers together, and you have n minus 1 is equal to 8. So to get n now, n will be equal to 8 plus 1. So n is equal to 9. Therefore, our r is equal to 2, and n, which is the number of times, is equal to 9. Please don't forget to subscribe to my video channel by clicking the subscribe button. Thanks and God bless you.